Hello there, and welcome back. What we're going to do in this video is use power-reducing identities to write sine to the fourth of x, or sine of x raised to the fourth, as an expression containing no powers. So what this is going to require us to do is to use power-reducing identities, which we see here in the box. So keeping in mind that sine to the fourth of x is sine squared x times sine squared x, we can now make substitutions that will reduce the power. So sine squared x is 1/2 minus 1/2 cosine 2x, and the other sine squared x is also 1/2 minus 1/2 cosine 2x. And then we basically FOIL. So first times a first is 1/2 times 1/2, which is 1/4. Multiplying the outer terms together, we have 1/2 times 1/2, which is 1/4 with a minus sign in front, times cosine of 2x. And it turns out the inner product is the same thing. And multiplying the last times the last, negative 1/2 cosine 2x times negative 1/2 cosine 2x is positive cosine squared of 2x. Okay, so we'll combine like terms. We have 1/4 minus, so we have subtracting 1/4 cosine 2x, subtracting another 1/4 cosine 2x. That is basically subtracting 1/2 cosine 2x, and then this plus 1/4 cosine squared 2x. So at this point we have transformed the fourth power into an expression with a second power. So we're almost there. So making a substitution for this one now, cosine squared 2x. So if cosine squared of, I'm going to highlight this in yellow here, if cosine squared of x is 1/2 plus 1/2 cosine of 2x, then if I have 2x on the left-hand side, that means I double the angle on the right-hand side, making that a 4x. So this will be 1/4 minus 1/2 cosine 2x plus 1/4. Now cosine squared gets replaced with 1/2 plus 1/2 cosine 2 times 2x, which is going to be 4x. So 1/4 minus 1/2 cosine 2x, plus I'm going to go ahead and distribute the 1/4 right away. So this is 1/8 plus 1/8 cosine 2 times 2x is 4x. And now we'll combine like terms, which is basically just the 1/4 and the 1/8. 1/4 plus 1/8 is 3/8. So you have 3/8 minus 1/2 cosine 2x plus 1/8 cosine 4x. And that is an equivalent expression for sine to the fourth of x, written without any powers, which you might be wondering why we apply this identity. This is going to be an identity that's very helpful if you go on to calculus, more specifically calculus 2. Turns out we can deal with trig functions with multiple angles much more easily than we can deal with powers of trig functions in certain situations.